Okay, this is part 5 of stress and health. How does the human system recognize abnormal cells? The immune cells, again, they work by braille. They have to feel the other cells, the other thing that they're encountering. And they have what are called PRRs, pattern recognition receptors. And there's pattern recognition receptors for what is called MAMPs, microbial associated molecular patterns, like a bacterial infection. There's PAMPs, kind of a non-specific term for pathogen associated. Pathogen means something that causes harm in the body. Pathogen associated molecular pattern. There's DAMPs. You can have tissue damaged by trauma or damaged by an infection, and that's DAMPs, damage associated molecular pattern. You can have cancer cells, which are abnormal, that the immune system is supposed to recognize to get rid of, and those are called CAMPs, cancer associated molecular patterns. So the immune cells feel stuff. That's why the immune system works better when it's hot, because it moves around faster to feel everything faster. That's why it works better when you exercise, because it gets flowing around through your lymphatic system and it feels more things more quickly. You know, caffeine might have a little bit of a decrease in DNA repair. I'd have to see more papers before I'm completely convinced of that, but you know, here's some papers to that effect. What is the effect of cortisol on telomeres? Telomeres, you know, the end of the chromosomes, and it shortens the telomeres, suggesting that it contributes to, the cortisol contributes to accelerating aging. So constantly being stressed out can accelerate your aging. What is the effect of stress on the body stores of magnesium? We talked about that. It increases magnesium excretion in the urine, so it predisposes you to being magnesium deficient. And you can even get, there's a theory of magnesium deficiency being a vicious cycle with stress. So stress makes you pee out your magnesium, you're low in magnesium, then you can't run your ATP pumps as well, because you need magnesium to hang on to the second and third phosphate in ATP for ATP reaction, so the third phosphate doesn't break off prematurely, so the reaction will run correctly. And when you're low in magnesium, you're less able to do that. Plus, magnesium also is like heroic in the sense that it blocks the NMDA receptor, the calcium channel that allows calcium in the neurons to activate them. So when you don't have magnesium on the board, remember from magnesium, M for magnesium, M for mellow, you're more prone to being hyper agitated, impulsive, like you're stressed out. Okay? So a lot of people are magnesium deficient. That's very common. Okay, that's the vicious cycle of magnesium deficiency. And why is that? Because magnesium normally binds to the second and third phosphate of adenosine triphosphate, so ATP, adenosine triphosphate. That's the energy molecule, by far the most important one. It's like a $20 bill in a cell. And you need the 2+ charge of magnesium to keep these negatively charged phosphates, second and third phosphate on ATP, from repelling from each other and bursting apart. You don't want that to happen prematurely, or you can't run your reactions. So magnesium keeps that in control, like hanging on to 2 wild horses. So you need magnesium. Where do you get magnesium from? Where do you think? What's the answer always going to be? Anything good comes from plants. So there's magnesium right in the center of chlorophyll. You eat your plants, you eat your green leafy veggies, and you'll get your magnesium right there. What happens to your blood pressure with stress? Your blood pressure goes up. We talked about your catecholamines increasing your heart rate, your strength of cardiac contraction. We talked about cortisol having a mineralocorticoid effect to retain more blood volume, reabsorb more sodium from the kidney. Cortisol also inhibits endothelial nitric oxide synthase. Okay, you need blood flow to the muscles, but you don't need it going to other places. Okay, during stress, what happens to wound healing? It gets worse, because you don't need to worry about wound healing when you're just trying to survive the next 5, 10, 15 minutes. What is the effect? So if you want to heal a wound, lower your stress level as best you can. Avoid anything that stresses you out. What is the effect of stress on body weight? Briefly you get insomnia, and in an initial acute phase of stress you could lose weight, you're so stressed out. But chronically it usually leads to craving, eating sweets and junk food, and usually leads to obesity and more diabetes and hypertension over time. What is the effect of chronic stress on human metabolism in the Western disease? It makes them all worse. Okay, you overeat junk food, you get fat. The stress makes you hypertensive. It increases your likelihood of diabetes because you got hyperlipidemia. So it worsens metabolic syndrome. Okay, and those two things, hypertension and diabetes, feed into causing atherosclerosis. That plugs up blood vessels all over your body, increasing your risk of heart attack, AFib, congestive heart failure, premature cardiac death. Increased atherosclerosis can cause accelerated spine degeneration, chronic back pain, degenerative disc disease, and all the stuff that goes with that, OPLL, DISH, etc. brain neuronal degeneration, which goes with that, is cognitive decline, eventual dementia. Average American is mentally slow after 60, even earlier for a lot of people. What is the effect of stress on the brain? Mild stress causes a mild elevation of cortisol, and that's a normal part of daily living, responding to the challenges we face every day. That's good. Okay, an increased amount of alertness to do what you got to do. But severe chronic stress, like I said, can chronically overactivate the hippocampus, get the amygdala extra activated, and that can burn out your hippocampal neurons and cause them to atrophy, to shrink, and that's bad. Okay, so chronic high stress is bad. What about stress and stroke recovery? Well, you want to get it under control so you can recover better. So hippocampal atrophy, like I said, lowers your cognitive function. Okay, we're talking about metabolic effects of stress, giving you metabolic syndrome, diabetes, hypertension. If you overactivate a neuron, you can't get enough blood supply to it. That neuron can die and go into apoptosis. If a liver cell dies, it's not a big deal. You can regenerate it. But with a brain cell, each one has unique connections. So if you lose a brain cell, it's a bigger deal for those brain cells to die by apoptosis due to vasoconstriction to the brain with simultaneous elevated metabolic rate from the glutamate release being increased. So you don't want that because you can't truly replace that neuron in its original connections. Yeah, you can form some new neurons through neurogenesis, but that's a very limited process. Most of the time when a brain neuron dies, it's not replaced, so you don't want to lose those neurons. Okay, we're going to call it right there. We'll have the next session coming up here in just a moment, continuing with our stress chapter segments.